This is example 3. Using the average insolation on Earth, calculate the area of a horizontal PV array with an efficiency of 20%. That would be needed to satisfy the residential electric needs of a city of 250,000 people with an average of 2.6 people per household. And for each household also there is a power requirement of about 1,370 watts. So in this question is we will need to know the land size. Okay, so this is the area of this land for the coverage of solar PV. And in this example also we are to assume that we are using the average insolation on Earth, which is in this case is 168 watts per square meter. So this is the average 24-hour average insolation on Earth. So let's first list down all the given here so we will know exactly the different values. So the average insolation is given already. We can assume as 168 watts per square meter, and then there's an efficiency of 20% that is given here, and also we have the population is equal to 250,000 people. All right, so we are also given the average of average household of, so which per household we can say that there are 2.6 people per household, and then there's also a power requirement of 1,750 watts per household. So these are now given, and the question is to find the area. All right, the area of horizontal PV array. So in this case, what we are looking for is basically an area where we have a lot of solar PV panels here. All right, we have to calculate this area here, right? How much is this area? And this is connected to electricity grid, right? This electricity grid is connected to us as a community here, and this community has 250,000 people with a number of households. So that's the main question. And so based from here, we know that we are supposed to find the area, so we can easily go about the solution here. So first we have to put in our power formula, which is insolation times area times efficiency. All right, so this is the basic formula for solar PV power, okay, electrical power. So from here, we are already given with the insolation. Area is the unknown here. The efficiency is already given, and power is also unknown. But we are given various values to get that power. So once we get this P here, power, then we can calculate for the area. So area here is basically power over insolation, okay, times the efficiency. So this will be our main formula to get the answer for this problem. So in order to get the total power needed, so the total power PT, total power, we need to know how many number of homes, okay, number of homes times the power requirement per home, right? This is the power requirement per home. Okay, so in order to get this total power that we need to find the number of homes. And so with here, the power per requirement per home is already given, the number of homes is not. So we can also we can get the number of homes by, so number of homes, by calculating what are we given here? the total number of people in the community. So they have 250,000 people, all right? And we are also given 2.6 people per household. All right, so in that case, now we have the number of homes. We can calculate now the number of homes to be 9.6 times 10 to the 4 homes or households. All right, so now since we have that one now, we can calculate for the total power requirement. Okay, so the number of homes is equal to 9.6 times 10 to the 4 homes, multiply by the power requirement. So the power requirement is 1370. It's already given watts per house per home or household. So the total power is now 1.32 times 10 to the 8 watts. Right? So once we have the power now, then we can calculate for the area. So area is equal to power over insulation times the efficiency, in which case we have 1.32 times 10 to the 8 watts over the insulation of 168 watts per square meter times the efficiency of 20%. Right? So the area now, A, is equal to 3.9 times 10 to the 6 square meter, or we can say, because we can convert to kilometer because it's a big area, we can say that is 2 kilometers by 2 kilometers. All right, so now this is the final answer for this problem. So you can see that this is 2 kilometers by 2 kilometers. So this is not a small area, all right? So it's still a big area that you can provide this much number of people. So you need a really large land area so that you can generate the required amount of power just to have to give access or electrical access to all of the people in that community. All right, so these are just some examples of some calculations, basic calculations for determining power, area required, and also the use of insulation and other parameters for solar PV electrical energy generation. Okay, so some more examples will be given as an exercise workout for you and will be uploaded on Canvas. Thank you.